Look at your hand. Every atom in it has existed for billions of years. Those atoms have been inside stars, inside oceans, inside dinosaurs. They feel permanent. They feel eternal. They're not. One day, maybe 1 trillion years from now, maybe sooner, every bond that holds your hand together will snap. Not because of anything you did, because the universe itself will rip apart. This isn't science fiction, it's called the Big Rip, and it's one of the most terrifying predictions in all of cosmology. Here's what happens, how we know, and when we might expect the end of everything. To understand the Big Rip, you have to go back to 1998. Two teams of astronomers were studying distant supernovae, exploding stars billions of light years away. They expected to see something simple. The universe, they thought, was expanding from the Big Bang. Gravity should be slowing that expansion down, eventually maybe even reversing it. But what they found made no sense. The supernovae were dimmer than they should be. Dimmer meant farther. Farther meant the expansion wasn't slowing, it was speeding up. Something was pushing the universe apart, something invisible, something repulsive. They called it dark energy, and in 2011, the scientists who made this discovery won the Nobel Prize. But here's the part they didn't tell you on the news. Dark energy isn't just pushing galaxies apart, it's getting stronger. And if it keeps getting stronger, the universe won't just expand forever. It'll tear itself to shreds. We need to talk about dark energy, because without it, the Big Rip can't happen. Dark energy makes up 68% of the universe. We can't see it. We can't touch it. We don't know what it is, but we know what it does. Gravity pulls. Dark energy pushes. For most of cosmic history, gravity was winning. Matter was clumping together, forming galaxies, stars, planets. Then, about 5 billion years ago, dark energy took over. The expansion began accelerating. Now here's the critical question. Is dark energy constant, or is it growing stronger? If it's constant, the universe will expand forever, cold and dark. But if it's growing, if dark energy's repulsive force gets stronger over time, then eventually it will overcome every force in the universe. Gravity, gone. Electromagnetism, useless. The strong force that holds atomic nuclei together, snapped. That's the Big Rip. So what does the Big Rip actually look like? Let's walk through it, step by step, minute by cosmic minute. First, nothing happens. For billions of years, the universe expands like normal. Galaxies drift apart, but locally, gravity still holds. Then, about 22 billion years from now, if dark energy is phantom energy, the rip begins. First, galaxy clusters dissolve. The gravity that bound hundreds of galaxies together loses to dark energy. Clusters fly apart. Next, our own galaxy, the Milky Way. For billions of years, dark energy pulls harder and harder. Stars begin to drift away from the galactic center. The spiral arms unravel. Then, about 60 million years before the end, things get personal. The sun's gravity can no longer hold its planets. Earth breaks free. It starts drifting, a rogue planet, alone in the dark. Then, about 3 months before the end, Earth itself begins to stretch. Dark energy is now strong enough to overcome planetary gravity. Continents crack, the core expands. The planet becomes an egg-shaped blob. 1 month left. The moon is ripped apart. Its fragments scatter. 1 week left. The Earth's atmosphere is torn away. The oceans boil into space. 1 hour left. The planet itself disintegrates. Every rock, every mountain, every atom pulled apart. 1 second left. Molecules break. Atoms break. The strong nuclear force, the most powerful force in the universe, fails. Protons and neutrons fly apart. And then, nothing. Space-time itself is ripped to quantum foam. There is no where anymore, no when, no anything. That's the Big Rip. Okay, that was terrifying. But here's the question that matters. Is any of this real? The honest answer, we don't know. The Big Rip depends on something called the equation of state of dark energy, a number that describes how dark energy behaves as the universe expands. If that number is exactly -1, dark energy is constant. The universe expands forever, but nothing rips. Cold, dark, but stable. If that number is less than -1, even slightly, dark energy grows over time, and the Big Rip becomes inevitable. Current measurements put the number at -1.03, plus or minus 0.03. That means it could be -1.00, or it could be -1.06. In other words, we can't rule it out. And here's where it gets even stranger. Some physicists have proposed a little rip, where dark energy grows, but not fast enough to destroy atoms, only galaxies, stars, and planets. The universe would end, but not quite as violently. Others say dark energy might change over time. It could weaken, it could flip, it could turn back into gravity. The truth is, we're still blind. Dark energy is the biggest mystery in modern physics. Let's say the Big Rip is real. Let's say it happens in 22 billion years. What does that mean for us, here, now? First, it means nothing for our species. In 22 billion years, the sun will have long since died. Earth will be gone. Humanity, if it survives, will be unrecognizable, possibly post-biological, possibly spread across galaxies. Second, it means the universe is not eternal, not in the way we thought. Everything that exists, every star, every planet, every black hole, will eventually be unmade. Third, and this is the part that keeps physicists up at night, if the Big Rip is real, then we live in a universe that is actively hostile to structure, that actively fights against gravity, against matter, against life. Some philosophers have called this cosmic pessimism. The universe doesn't care about us. It's not just indifferent, it's actively working against complexity. But here's the counterpoint. The universe gave us the ability to ask these questions, to predict its own demise, to look 22 billion years into the future and say, "We see you." That's not nothing, that's extraordinary. There's one more possibility, something even stranger than the Big Rip. What if the Big Rip already happened in a different universe? And what we call the Big Bang was actually the other side of a cosmic tear? Some theoretical physicists have suggested that our universe could be the inside of a black hole in a parent universe, and that the Big Rip, the tearing of space-time, could be what triggers a new Big Bang. Every death, a birth, every rip, a new beginning. We don't know. Maybe we'll never know. But here's what we do know. We are here now, conscious, curious, alive. And as long as we are, the universe matters, because we're the part of the universe that gets to look back at itself. Even if everything ends, even if the Big Rip destroys every atom, the fact that it was understood by a brief flicker of awareness on a tiny planet around a mediocre star, that means something. The Big Rip may be our future, or it may not, but the question forces us to think about what we value, what we protect, what we leave behind. In the meantime, keep looking up, keep asking, and maybe, just maybe, find a way to make today matter. This is Cosmic Pulse, and no matter how it ends, the universe was worth it.